All right, good afternoon. Let's get going with a couple of presentations. So, how about the first collab Violet team shows off what they have? Danish, Michael, and Matthew. Is that you? Okay, well, show off what you can do. Yeah.
So you're right. We did just that, but also we need some check stuff. So just I need to fix that. But for
Okay.
the sake of the demo, I'll just save the files.
Okay.
I said it wasn't reading. I mean, it was using the old version.
Is it building?
Huh?
Is it building right now?
It builds, but then it won't.
Will it run?
It'll run the old version. I have to just open and save.
That's right. I just want you to demo right now so that people can see.
Okay.
Let me get you to. um, oops, there's 151. And you guys will collab Violet 1, right?
Yeah.
Okay. Okay, I just want them to see how you can build the client as a server and get it run.
Oh, that's it.
Yeah. Stand a little bit away so that you can turn it.
So just see in the. Well, I guess first I go into Violet. Just run ant.
Yeah, so you're gonna fix that part.
Yeah, I need to fix the Java doc.
Yeah, so here there's some error messages in Java doc. No error messages in check style it seems. Although I don't know that. What did we report them?
Yeah, and there's a check style.txt. But I haven't limited the amount of files it's checking to just the ones I modified, so it's getting errors from the other Violet files.
Yeah, you guys should limit.
Yeah, I need to fix that, but
Okay, so Violet builds fine.
Yeah. So I'll just do.
Will it actually run without the server?
Yeah, it'll start. It doesn't start till the class diagram is created or any.
Right, but so build the server.
Build the server now. Okay.
Yeah. Okay. Because it's no fun seeing it sitting there. So these guys also have a server component. Yes. Let that look bigger. That's right. You can't type in that. Yes, that's true.
So yeah, that should be up and running soon. So I'll just go to.
The menu's all the way top.
I was just gonna go open a new tab and then go to localhost. So. So it's not open a connection.
See what goes on in the server. Go to right here.
I don't know. Okay, cool.
Alright.
So yeah, so I just create a new class diagram. Okay, so now if I refresh this, oops, I did not press refresh.
Oh, yeah.
there we go. So that's the session ID that it works in. Now, let's say, so now what we have to do is we have to go to connect, and then the ID number 506036. So it's connected. So now, for example, if I create a node, and then let's say I delete the node. Oops. Delete. How do I?
Maybe from the menu edit.
So ideally, this would say, whoops, that again. Node is removed. Also, what else it can do is if I add this, let's do edit properties, to say this should work. Okay. So this should spit out a bunch of hex. Yep. So it fires it per keystroke, but this is the serialized property name and the value, and then it tells you the property. This is just telling you the non-hex, the property name value. So it fires per keystroke, but it goes. And then just another quick thing that feature I added yesterday. So let's say we close this. Yes. Okay, I was just going to switch the session.
But that's
Okay,
okay.
cool.
Okay, so what you see here, they have not the easiest project, and they're pushing this along so that these basic things are working, and so and I was able to build this thing, and so I thought that looked like, from the code perspective, like a healthy project. The other thing I've been looking at is the issue is the commit list. So let me put that up. So as you guys undoubtedly know, is I have a lot of information about. Oops, I know what's happening. Am I not online? I've got to be online. Yeah, let's go to another. Is GitHub down? Am I being... Come on. We'll pick one who's on. These guys on Bitbucket. Oh, I'm not logged in, of course. Oh, crud, now I don't remember my tab. My regular machine always logged into GitHub. Okay, well, I guess I can't do that. No, wait. One more try. It's not happening. Who of you uses Bitbucket? No, in this project. Why is this one point to get? Let's see, other droid. No, it's okay. I don't want you to make it public. Why is they all pointing to GitHub? Here we go. Let's see. Oh, all right. So here we have. So when I look at the list of commits, here we have a team that's done a very good job with frequent commits. So you guys can sit down for a second. So you see here, this kind of typical timeline where things kind of merge in and out as people do this. And so every day, whenever something is kind of stable, or even if it isn't stable, probably they just check it in. And so I can see, this thing going on. I can also see that this is a team of 3 people, and I can see who is really not committing very much, right? So that's definitely something that I will look at when it comes to looking at the final grade. So if you were the one who wasn't doing much of that, I would be worried. And the other way that I can see this is by just looking at the issues. With the issues, on the other hand, this team does a terrible job, where there's no issues worth mentioning. So there's other teams who've done a quite credible job with the issue, and where I see like 8 or 9 or 10 issues. And so then what I look is, I actually just count the number of issues and I eyeball whether they make any sense. And then I look at, are they evenly distributed? If it turns out that all the issues are assigned to a single person, then that's not so great. So this is something that, as a manager, you want to have insight in, is this project on track? Is it moving forward? And so it's very gratifying to me to see that I get that insight with just about every project. I have a pretty good idea of what how it's going and who's doing all of the work. So if you're currently among those who are not doing the work, get on it. And all of you should really be in a mode where you work on this for an hour or 2 every day. After all, you have no homework, and so I've looked at the self-reported hours for the projects where it looks a little pitiful. The number of hours look a little pitiful too. So you could make up for that by putting in a few more hours and getting that going. The other thing is that there have been a couple of people who their tasks were like, I'm going to study this. And we're in a university and we should study things, but that's not actually what people do in practice, because there's only so much reading and studying you can do. You really learn these things by doing. So when you set yourself tasks, try to set yourself tasks that produce something. I mean, it doesn't have to be producing a huge amount, but it should have something that's tangible where the code gets pushed forward. You all know enough about what you need to do that you can study by doing. So it's okay to say, I'm committing to doing this, and yes, I have to read up something, but at the end of the day, there should be a little bit of code that reflects that. So think about that as you move your tasks forward. You have, another 2 weeks, right? And then there's a few days of mop-up that that you will need. So any questions? Any stuff that doesn't work out for you? There have been a number of teams who've contacted me for strategic advice. How should one do this? How should one do that? So if you're stuck with something, by all means, send me an email or arrange a meeting with me, and we'll work through that. Yeah.
Even though I added it to the project, but I'm not in the contributor, I don't know why. So we'll try to fix it.
You need to fix it. You will get no credit if there's no commits.
But I have commits there.
Well,
it's just the contributor side, so by the GitHub.
And get it. If you have commits in GitHub, why are you not a contributor?
Really don't know what happened there.
But as long as I can see that you are a contributor, do you have tasks assigned to you? Do you have issues assigned to you?
Yeah.
Do you have commits that show up?
Yeah.
Then I don't care. Okay, you guys can figure that out, but I really don't care. As long as I can see those things, then I'm good. All right. Other questions about the project? All right, keep at it. And so I keep nagging you once a week about the things that you should have done, and you see that in these checklist reports. Read them and do better next week. So I understand this must be intensely frustrating to always be told this isn't up to standards, but it's the way it goes, right? I try to push this to a good level of quality, and overall, I think things will come together. And clearly, as the professor, you always wanted that to happen faster. All right, so let's look at today's set of slides. So today I wanted to have a bit of a closer look at how that Violet framework is put together, not because it's a framework that you will ever use outside class, but it's a really nice example of the framework in that it shows the separation of the framework code and the user code. It's simple enough that one can understand all of it, and it's complex enough that it does something useful. So in the traditional approach, of course, for making programs such as these graph editors, one starts from scratch, or maybe you have some kind of a library. But with the framework, it's completely different. The framework tries to do everything that is common to all of the applications. In the case of Violet, the framework handles all of the UI. So when you extend this graph editor framework to add a new graph type or just a new node type, you don't worry at all about the user interface. There's not a single mouse handle or anything that you need to touch. The same thing with basic functionalities such as loading and saving, or even editing of properties. All of that stuff is done by the framework. So if you want to put something into this framework, then you need to extend the given graph, node, and edge classes, and that's all you have to do. So you're, of course, familiar now with this user interface here. We have here these. So we have here the toolbar. Here we have the graph, and so in fact, just to show that how some of these things are done, when you so here obviously we have two node types, the black and the white circle, and we have one edge type, and these buttons then appear absolutely automatically. We'll see in a minute how that happens. So let's think of something. Let's say you want to put in a new node type, like a transistor, and let's see which parts are handled by the framework and which parts are handled by the specific code. You have to tell how the transistor is drawn. There's no way that the framework can do that. So you have to provide a draw method, and the draw method has to produce the usual drawing commands. You have to give some idea of telling me whether the mouse is inside the transistor. So you're going to have some node that looks like, what does the transistor look like? So you have to kind of tell me that when the mouse is here, then it's not in the transistor, but if it's here, that then it is. And you do that by telling me what are the bounds of this shape. When it comes to like dragging the thing later, you don't have to worry about any of that stuff. That's done by the framework. So now let's look at how some of this stuff works. Like look at the toolbar. So the framework wants to draw the toolbar, and what you have to do is when you want to use the framework is you have to give a list of nodes and edges so that I know what to put in the toolbar. And then there's a question of how should one specify that? So when I designed the framework, I had to figure out how should a programmer who uses that, how should they tell me what to draw? And so I thought there might be three possible ways that they could do that. They could give me just the name of the class as a string. So you, the user of this framework, you would tell me, I'm going to give you just an array of strings, transistor, resistor, whatever you have in circuit diagram. That would be one possibility. Another possibility would be that you give me a list of class objects, of all of the classes. And a third possibility would be that you would give me a list of sample objects, so to speak. One object of each type, a new transistor, a new resistor, and so on. So those are the three things that I could think of how one could do that. There would be other possibilities. You could just give me a directory and have me look for classes in there or some such thing. But these seem like straightforward choices. And so the way that I've done it is I've chosen the third pattern where you're going to give me a list of objects. And the reason is that way objects are a little bit more flexible. You could give me a black circle node and a white circle node, and there would be two different things. Whereas with a class, you then have to make two separate classes for black circle and white circle. And so here's what I then do is you're going to give me all of these objects, and then when someone wants to make a new object, so they click on the toolbar, and then they click somewhere, and then it needs to get inserted. Now I already have an object of just the right kind, and how do I get another one just like it? Well, that's what cloning is for. So I just clone your object, and then I put it in the right place. So you see the code here. So I have inside the toolbar, inside the toolbar button, I have one of these sample objects. I call clone in it, and then I just insert it at the mouse position. So that's a very general mechanism. I don't have to know anything what you give me. You can give me a transistor or an armchair or whatever. I just call clone, and thereby another one appears. So this is actually a very useful general pattern called the prototype pattern. And so no, I don't want to go into detail in the prototype pattern. You can read that, but I think it's intuitively obvious what it is. So let's go to the picture. So each of these buttons here has an object inside, the prototype of what one wants to achieve when one inserts it. So let's say this one here is selected, then I click on here, then all I do is I clone this guy. Now you know why you had to learn about cloning, because it's an obviously useful thing. So the prototype pattern says that if you need to give someone a collection of kind of similar objects that they need to do something with, in particular that they need to generate new elements of, just give them these prototype objects and let them clone away. Yeah.
But Android, it's quite different from Java. So it could be hard to apply patterns. The global patterns. Android has its own patterns.
No. If you look at this, let's say you wanted to do this kind of stuff on Android. Right? Now, you were not necessarily tasked with doing a framework on Android. So no one said that your thing has to work both with UML diagrams and with transistors. But you could just copy and paste the mechanism that I have. You could say, you're going to make yourself a bunch of buttons. And I must have had a class for these buttons. And of course that class in Android is going to look somewhat different. But the basic idea of saying that each of these buttons has an object, and that then when the button is selected, and someone clicks with the mouse here, you find out which was the selected button, and you just clone what's under it. That, I think, seems helpful. It seems less work than implementing it from scratch. But what you probably have right now is you have a bunch of custom buttons, each of which has a logic to do something. I'm guessing. So there is some wisdom to try to find out, which shortcuts you can take from this. All right, so that's one useful pattern that makes the toolbar work. Another thing that's been an issue when you draw these kind of things is you don't really know how the how the shapes of these things are, and you need to know that in order to connect stuff. So let me motivate this here. So let's say I have a rectangular node that looks like this, and then I have like a circular node that looks like this. And now I somehow want to connect them. And how do I do that? So of course, the connection kind of roughly joins the two centers. But then this stuff here gets drawn inside here, and it gets drawn inside here, so that's not so cool. So one needs to have some way of finding out what are the points on the outside that actually should be joined by a line. Those are the ones that are here and here. Now that's something that I can't figure out in general because I don't know what the shapes of these things are. And the shapes could be crazy looking, right? What if it's a transistor? You know, I have no idea where to connect anything. Right? With a transistor, the connection points would have to be this one, or this one, or this one, depending on where one comes in. That's something that only the transistor knows. That's not something that the framework would know in general. So there's one of the methods in the node class that says, I would like to make a connection from this exterior point to your node, presumably to your center, or wherever, and you need to tell me, given this point, where should I connect to? For a circle, it's just a bit of trigonometry, right? You just figure out what is this line and what is the circle and the intersection. In the UML editor, it's a little bit more different because you don't actually want to connect like this. You only want to connect here or here or here or here. Otherwise, it doesn't look pretty. And so that's something that the implementer, that the framework programmer, I shouldn't say that the programmer using the framework just has to override this method. Do I have the exact method here? Yes. So here the method is called getConnectionPoint. So this is a little bit old school still. There's no default methods. Here's an abstract node class, and it has some implementation of it where it says, I'm just going to connect the centers. So one could do a little bit better than that, and in the real Violet framework, I do a little bit better than that by making some shape approximation, but here in the one that's in the book, it just does something simple. All right, so that's so let's look at this graph class here, what you have to do. So for when you want to have a new graph type, the graph is a concrete class, and it has concrete methods. So it deals things with connecting, for example. So here you can see when you ask the graph and say the graph should connect this edge, and these 2 points are the points in the various nodes, then it calls the edge connect method that says now the edge is attached to these. It adds the edge to the set of edges, and why does it do these things? For whatever reason, I'm making it find the nodes under these points because the graph has that responsibility. There's a find node method down here that to find a node looks at all of the points. So all of this is stuff that you could read through. Here's a draw method. The drawing is abstract, but the graph can draw the nodes by just going through all of the nodes and drawing them, going through all of the edges and drawing them. So removing nodes is similarly pretty simple. So when you look at the graph, you can see that it's visual in that it knows that it has something about drawing, but it has no user interface. And so that's an important thing to remember also in your own design, that you want to carefully differentiate between the model, that's the graph and the nodes and the edges are part of the model, and the, the controller part, that's all of the stuff that has to do with buttons and mouse clicks and so on. Now here are a couple of abstract methods. So get node properties, prototypes, and get edge prototypes. Those are the ones that, that when you want a new graph, you just have to give a list of the sample nodes. That's all you have to do. Once you define those two methods, then you get your new graph type. So I'm not going to talk about the UI class because you don't care. But I'm going to show you what you have to do to plug in something there yourself. So to do that little application with just the circular nodes and the line edges, there is a node interface here. And then you have to just make the circle nodes happen. You have, here's the edge interface, it's an abstract class. And over here is the line edge that joins two circles by line. This simple graph here, all you have to do is to say, I am a simple graph. I have two prototypes, a black circle and a white circle of nodes, and I have one prototype for edges, namely this straight line edge. And that's all. So this is just the two lines here. The rest of it, all of this stuff here, is all framework code, and you, the user of this framework, just take it for granted. You don't have to worry about any of this. So let's look at the code for these here. So what does the circle node have to say? It says, okay, here's some constructor, it stashes away color. Here's clone. Unfortunately, clone has to be defined here, even though it's completely mechanical. Here is the draw method. The circle needs to say, I draw myself by drawing a circle and filling it with a color. The circle does have to define what translate is, what it means to move itself, and that means it moves itself. It needs to do hit testing. It needs to know what it means to contain a point, and it is when the point is contained inside the circle. It needs to say, what are my bounds? That's the rectangle that encloses it, and it just computes the rectangle. And then it needs to do this computation of the connection point, and it does that by doing calculating some distance and some trigonometry. Actually, it doesn't even need trigonometry. It does some vector computation that we don't care about. For being an edge, it's even simpler. To draw an edge, we simply draw the line that we get from the connection points. In this case, this is a straight line. If we wanted to have like a dotted line or a colored line, then we would do something else. Also, the UML editor has to work harder here because when it wants to draw these lines here, as you know, these are these funky segmented lines. Yeah, so it can't just draw a straight line from here to here, but it has to figure out what is halfway in between. How should it do this kind of stuff? That's more work. Undoubtedly, some of you have seen that code when you try to replicate that elsewhere. And here is the simple graph. So the graph simply says, here are my node prototypes, here are my edge prototypes. That's it. And now you have a framework that can do this. So all of this is super abstract and not very interesting to listen to. So I figured I make this into I make a lab where you can try this out. So from the book code, refresh the repo so that you have the latest and greatest. Make a copy of this GraphEdge2 directory. Call the copy network. And then we're going to be making like a little social network editor out of this. Um, so the simple graph and simple graph editor, we call them network graph and network graph editor. And then I want to add a class person node to this that represents a person in that social network. And so right when you start out, we're going to have person node extend circle node. And so the people will show up as circles. And that, of course, isn't so cool. Instead, we want to have the people show up as images. So I've given you a bunch of sample image here of possibly recognizable characters if you read the news. And so the way to specify these images, I figured, so that you don't have to like load images onto your local computers, just give the image URL. So when you right click on one of these images, you get a URL, and you can copy and paste them. So then, of course, at some point we'll want to make these images show. So there is a method to do that with paint icon. And when you go through all of that, you will have like a little editor where you can draw people and you can draw lines between them to show who is friends with whom. And the absence of the line would show that they're not exactly friends. And if you have extra time, then you can follow along this, and then you can make the images circular like they tend to show up these days everywhere. But if not, don't worry about it. That's just some graphics work. Okay, so get together with your buddy and have at it and see how far you go. And then at the end, we'll talk a little bit about what it is that you needed to know and what it is that the framework gave you. Okay, do we have an even number of people? Yes.
There's no particular reason to use GitHub.
As opposed to what? Huh? No, NetBeans is fine, yeah. Supernode.
These are all not,
Size. Person node. Default constructor. Default constructor. Super. Network. Oh, network. Alright. Okay. Okay. one? Oh yeah, yeah. So okay. So is everyone around the point where you can see where you have a circle? Okay. So now when you look at the properties of the circle, so edit properties. I don't think the right clicking works in this simple thing. You see, there's a field for the image URL, right? How did that field get there? Did you program it? How did it get there? How the heck does the framework know that, well, what does the framework even know? So it has a field for color, and it has, with a funky color editor from the Mists of Time, and it has a text field for the image URL. How did it know? So it must have somehow looked at the person class, and so at the person node here. And so how does it know? Does it make one for every field that it has? Like you added an image URL field. And I don't think so, because look at the color class. So it did figure out that it needed to give an editor for the color. And sure enough, there's a field for the color. But it did not give editors for X, Y, and size. How did it know that the color was worthy of an editor, but X, Y, and size were not? Aha! That is exactly right. So when something has a get and a set method, then you get an editor field. So if you look, and it has to have both a get and a set method. Like there's a get bounds here, but no set bounds. So that's not good enough. But with the color somewhere here, there must have been a get color and a set color. Here's a get color and a set color. And that pair of setters and getters, that was enough to make the property sheet here to say, okay, I'm going to put in an editor for it. So there is a mechanism that we haven't talked about that's described in the book, but we just didn't have the time to cover it, where whenever you have a class, you can automatically find out what are the things in the class with getters and setters, so they're called properties. So you can enumerate all the properties. And then and that by itself is not very hard. You can just look for methods that are called getFoo and setFoo. You could do that by hand. But the other thing that's awfully nice is whenever you have a property, then it sees what's the type of the property. The image URL has type string. The color thing here has type color. And then it looks at, do I have an editor for that type? And then it pops the editor in here. So you don't have to do any of that. So as long as there is an editor for it, then it'll work. If on the other end you produce a type that it doesn't know how to edit, like URL, it doesn't know how to edit, then that it wouldn't show anything. It's possible to add editors in there for new types, but that's more advanced, and we're not getting into that in this course. Yeah, it looks at it looks at the color from the superclass because it is a property of the class. The class does have a getter and setter; they inherit them. And after all, you might want to edit them, right? So, I can't figure out how to use this stupid editor. I always replace it. I guess you just pick colors here, and I guess you can edit these here. Yeah. All right. So why doesn't it? So let's put something into the URL. That's I have to do this edit properties. So let's copy. Copy image address. Okay, so now I'm putting it in here. Why doesn't it show Donald Trump? It hates Donald Trump, right? So I've hardwired so that it'll show anyone but Donald Trump. No, not quite, right? Why doesn't it show Donald Trump? So far, we just have a string there, right? So we need to draw it. So move along and draw it. where do I do all this? Call the paint icon method of the image icon. There we go. Oh, I see. I see. Swing you can only draw in response to someone wanting to draw. So you are setting the image viewer up, but that doesn't mean that you're going to be able to draw right away. So if you figure out which method you need to override, then that's wrong. That method will be called right. So look at the in the node class, I guess, and see what method. Or maybe you can even look in the circle node. Nope, that's an obvious method. Yes. Because the shape should be 50. Yeah. All right, so I think that's how far we want to go. Um, so which method do I need to override for the drawing? Draw, right? So in person node, I need to specify what draw is, and so here I've already put in the thing with the round clip that we can ignore right now. But so why can't I just do it right away in set image URL? Why can't I do the drawing in set image URL? Yeah, it's the Hollywood thing, right? Don't call us, we call you. So the drawing happens at some point when the user interface feels ready to repaint, and then it calls the graph and says, draw yourself, and then the graph has to go through all of the nodes and edges and say, draw yourself, and so we have to be ready to redraw, and so in here you need to check whether icon's not equal null, right? Because at the beginning it could be null. And then you call paint icon, and you just have to remember, what did paint icon need from lesson 3? It needs the parent component, which we don't know, so we just use null. It needs the graphics context, and then it needs the top left corner. Well, how do we know the top left corner? We can ask what are the bounds. Somehow the thing knows where it is, and so get bounds gives you a rectangle 2D, and then you call get x. So we can kind of cut off here. We call get x and get y on that. Inconveniently, they return doubles, so we need to cast them into ints. And that's how you draw. So the things that I added on here now was that I copied from the next slide, where if you want to have the thing appear circular, then you set what's called a clip. That makes it so that you can only draw inside the area that you set here. So I'm clipping to an ellipse, and that has the same x, y width and height as the bounds, and then it looks like you can see here. Yeah, that's just so that it looks prettier. So what did you have to know about doing graph editors in order to... So you obviously didn't need to know anything about buttons and mouse motion and any of that stuff, right? That was all done for you. You needed to know how to draw the thing. No one can take that responsibility away from you. Do we need to do anything else? Yeah, and so that was, we needed to provide the properties. The property of this thing was the image URL. We needed to provide the property getters and setters. And this is a really good example of a property where the getter and setter don't just get and set. Sure, the getter just gets, but the setter then also does some extra work. Right? So that's why it actually having a getter-setter pair is more useful than just having a field, because you can do stuff in the getter and setter, as we're doing here, right, where we're loading this image icon. And but that's it. So you have to know the rules of the framework, and of course I told you, because there's only so much you can learn in a few minutes. But once you know those rules, it is pretty easy to use. And so that's the point that I wanted to get across, that this is a powerful technology to bundle a whole bunch of non-trivial expertise so that someone can make effective use of this without having any of that expertise. You've now seen it twice. You've seen it with that server-side framework that we had on Tuesday that let you do a super simple web application without having a clue how to write a web application. And now you've seen how to write this GUI application without knowing all that much about GUI applications. So that's the point that I wanted to drive home about the power of these frameworks. So those of you who are working on Android or on FX, it is worth your time to read this chapter carefully, at least that section on Violet, and see what good ideas you could possibly harvest here. Some ideas are easily harvestable. Some of them are not so easy. Like the thing with the property sheet, I would agree has no analog in Android, and you'd have to come up with some other mechanism for it. Any remaining questions? Okay, so yeah, submit your lab reports, and so that I have them for the participation grade, and work hard over the weekend on this project. Any questions about the project, feel absolutely free to send me an email. If you're stuck, you want strategic advice, I say it again, send me email and I'll give you pointers.